Hello, in this video I'm going to do Derivation 2.6 LRS 082. So, as usual, we start with show conclusion, and when we look at the this bicondition with the conclusion, we might ask, how are we going to get the conclusion? How are we going to box and cancel the conclusion, really? And it's not a conditional, so we're not going to use CD, so it's going to be with DD. And now, so then we ask, well, how would we do that with DD? Well, we're going to get, we'll need to get Q if and only if P. So now we need to ask, well, how are we going to get Q if and only if P? And the answer is, well, we use CB, the rule that says if you have the conditional going one way and you have the conditional going the other way, then you can infer the biconditional. So we're going to use CB with if P then Q, and if Q then P. How do I know that? Because it's a biconditional. And how do I get biconditionals? With the rule CB. And so if we don't remember what the rule CB is, let's go and look in our text or in our notes or at the videos. So how are we going to get it? It's not a conditional, so we're going to use DD. Or how are we going to box and cancel? It's not a conditional, so it's not going to be CD, so we're going to finish with DD. Okay, how are we going to finish with DD? We're going to get the actual conclusion. How are we going to get the conclusion? It's a biconditional. How are we going to get a biconditional? The rule CB, and this tells us what we need. So, okay, good. So we have some sense of where we're going. So our first step is to show the conclusion and then ask how do we get the conclusion. Second step is to say, okay, can we make an assumption? Answer, no, because we're not trying to show a conditional, so we're not going to make an assumption. So let's put in our two premises. We have if not Q, then not P, and we have if Q, then P. Okay, well, can we apply any rules to 2 and 3? Can't do MP, can't do MT. Actually, we don't care about MT or MP or MT very much, probably though, because what we want to do is get a biconditional anyway. And if we think, well, how do we get the biconditional? Well, we say, well, we figured that out. We use CB, and we need if P then Q, and if Q then P. Oh, well, look, we already have if Q then P already. So we already have one of the two things we need. In a way, we're halfway done. All we need to do is get if P then Q. So, well, the derivation is stuck, and we know how we want to finish it. We want to get if P then Q. So let's do a subderivation. Right? We said derivation is stuck. Okay, so do a subderivation of what? Of what will help complete the derivation, and what's going to help complete the derivation? If P then Q will help us complete the derivation, because once we finish it, however it goes, whoops, that's not what I wanted to do, then we'll say 3, 4, CB, and we'll get Q if and only if P. That's why we're doing 4. That's why we're doing that show line, because we can use 4 once it's canceled with 3 to get our conclusion, and then we can box and cancel. So that's why we're doing 4, because it's going to let us do those steps. Good. So let's see, let's get rid of this line, and let's get rid of that line, and let's get back to here. And let's actually try to do this subderivation then. Well, we're trying to show a conditional, so we can make an assumption. Good, we can get P. So now I want to ask, okay, can we use P? We're not going to use it with 4, because 4 is an uncanceled show line, and we can't use uncanceled show lines. So with 5, we got to look at 3 and 2 and see if we can use it with 3 or 2. We look at 5 and 3, they're not going to do anything together. 3, for MP we need Q, and that's not what line 5 is. For MT we need negation P, and that's not what line 5 is. And not only is line 5 not negation P, but we can't turn P into negation P. We wouldn't want to do that, because then we'd have a contradiction. But what about with line 2? Well, for line 2, MP we need negation Q. We don't have that. No. I'm sorry, I misspoke. For MP, we need negation Q, and we don't have that. What about MT? Well, for MT with line 2, we need negation P. We need double negation P. And that double negation P we can get, because 5 is P, and we can turn it into double negation P. So we can say 5dn, oops, line 5, gets us not P, negation P. And that's what we need for modus tollens with line 2. We get not negation Q. We have negation Q. Can we do anything with that? Well, we can't box and cancel. To box and cancel line 4, we need either P arrow Q or Q. And negation, negation, Q is neither of those. But negation, negation, Q can turn into Q with D and E. And now we have the consequent of line 4, so we can say 8 CD. Okay, good. So now we have completed our subderivation. Maybe we forgot why we did this subderivation. Well, we look down here. We said, oh, will help us complete the derivation. If P then Q. Why will if P then Q help us complete the derivation? Look up here. Oh, because we can use CB with it and line 3. So we can say 3, 4, CB, and that will give us the conclusion. And, oops, I keep doing that. And there's our derivation. And again, this incorrect is just because of this stuff. Not the derivation itself is correct. So, again, it's the same process of reasoning. We need to think about what is the conclusion and how can we get it. And then when we get stuck, we do a subderivation that will help us get the conclusion. And in this case, the conclusion is a biconditional. How do you get a biconditional? With the rule CB. And what do you need to use the rule CB? You need the two conditionals. So when we look here, we already have one of the conditionals, so we think, well, let's get the other one. We put them together, and we get our conclusion. And how do we complete the subderivation? Well, we make this assumption, and then with that assumption, we see how can that assumption work with our earlier lines, and our earlier lines that besides the show lines, because they're not canceled yet. So we look with 5 and 3 and 2, and we see, okay, 2 and 5, and we get to Q, and we box and cancel the subderivation, and then we put it all together, and we're done. So that's derivation 2.6 LRS 82.